Rob, thanks for your laudable introduction. Good morning and welcome to our second presentation. I'm here to share with you what we're doing in the asphalt construction business as it relates to sustainability. But before I do that, let me just share a little story with you. As you know, in the construction business, there is bragging rights between asphalt and concrete. So one time I heard this story where the asphalt guy asked the concrete guy, what happens to concrete when it's at the end of its service life? So the concrete guy goes, well, it's overlaid. So the asphalt guy goes, so what you're saying is asphalt is the material of choice used when our good friend concrete needs a decent burial? That said, I'd like to share with you a buzzword for this morning, which is sustainability. In fact, I told my 7-year-old I was going to give a presentation in Dallas, and he said, what are you going to talk about? And I told him I'm going to talk about sustainability. And he said, Dad, what's that? I said, it's a fancy word which means, number one, it's great for Mother Earth. Number two, it's good for our local community. And number three, it makes financial sense. Currently, there are 3 best practices in the asphalt paving business that speaks to sustainability. Number 1 is recycle asphalt shingle, for short RAS. Number 2, recycle asphalt pavement, RAP. Number 3, warm mix asphalt, WMA. Due to time constraints, my presentation this morning will be on the first 2, RAS and RAP. And with that said, we'll go ahead and cut through the chase. So with RAS, pose a couple of questions in preparing this presentation. Number 1, what do we know about RAS? What was done to get us to this point? Why was it done? What we're doing with it? What tests? What's the state of the practice at this time? We've used it for a couple of years. How is it performing? What do we use it for? Is it all things to all pavements? What are the cost benefits of RAS? And finally, a couple of projects. I'm from the Houston area. A couple of projects in the Houston area where RAS has successfully been used. Just a quick background, approximately 13 million tons of asphalt shingle waste is generated per year. And we can break it down into 2 categories. Number 1, post-manufactured RAS, which is as they produce this product, the waste that's generated during production. And then number 2, there's post-consumer RAS, and that constitutes 11.5 million tons. And this is what comes off our roof once the RAS comes to the end of its service life. Unfortunately, less than 5% of shingle waste is recycled. If we look nationally, The green means they're using manufactured wraps only. Yellow means they're using both products comprising the waste as well as the tear-offs. So if you look at Texas, we're in the yellow, so it looks like we're doing something good. So what are the components of RAS? So if I look at the picture in front of us, the top we've got granular aggregate sitting on top of waterproofing asphalt, which in turn sits on top of a base, which could be either fiberglass or organic felt. And underneath that, we've got waterproofing asphalt, and at the bottom, we've got back surfacing. So if we do an analysis of those ingredients, looking at just the organic felt part of it, so asphalt, cement, you can have anywhere from 30-36% of your RAS is asphalt, 2-15% is felt, 20-38% mineral aggregates, and 8-40% mineral fill. So in essence, we have asphalt as well as aggregate in RAS. We know that shingle asphalt is stiffer than paving asphalt. And how do we know? We ran some tests. The leftmost column, which shows binder, shows you a conventional asphalt binder, which is your PG 64-22 grade. And then at the bottom of that leftmost column is shingles. So if you look at the PG grade for asphalt, it's 67. The PG grade for asphalt coming out of shingles is 9-6. Why is it so? It's because coming off the refinery, asphalt put in the shingle is kind of like in pristine condition. So after 10, 15, 20 years on the roof, it's exposed to the element, it gets stiffer. So that number goes from 67 to 9-6. So the bigger the number, the stiffer your asphalt. And if you look at also on the rightmost column, your PG 64-22 asphalt binder, which is the buzzword is virgin asphalt, has 5.2% asphalt in it. If you look at shingles, the asphalt content in shingle is about 24%. That's huge. We know that shingle is good for the environment. Next, what was done? How did we start introducing shingles into asphalt? The first research project in Texas was on SH31 in Navarro County, and that was back in May 1997. And they did some research. So they put down 2 test sections and 1 control. So test section 1, they use 5% manufactured waste. Section 2, they use 5% tear-offs. And in section 3, they used the control, which was vanilla. And they compared all 3 sections over a given period of time. Originally, they had some issues with the tear-off section, but overall, all 3 sections performed well. Why it was done? 3 good reasons why it was done. Number 1, it's a good source of asphalt. Number 2, it reduces landfill consumption. And number 3, it conserves our national resources. Someone had to tell the asphalt industry, hey, do this. And one of those entities was the Texas Commission on Environmental Quality. And they came to the asphalt industry back in March of 2006 and said, hey, allow the use of manufactured waste in asphalt. And we suggest you treat it as RAP, which is asphalt, recycled asphalt pavement, and use up to 15% as a substitute for your virgin material. Then in 2009, they came back and said, consider the use of residential tear-offs as well, but make sure that you test for asbestos, keep asbestos out of it, and also cap the percent of deleterious material. Deleterious materials mean wood, nails, everything that's not good for road construction. Text that came behind TCEQ and say, it looks like it has some merits, so we'll come in with some special specifications that will allow the use of waste and residential tear-offs. And text that went in and said instead of 15%, we recommend using a maximum 5%. Based on the initial test sections, they realized 15% did not work. It had issues, so they capped it at 5%. They said, yes, it's good for you to test for asbestos, and furthermore, limit your deleterious, instead of 1.5%, bring it down to 0.5. And then they caution the asphalt people that it will be nice if you limit the material to 100% passing the 3/8 inch. So you've got to crush it. And in addition, they said you could combine your RAS with RAP with WMA. The next slide is a summary of RAS specifications. So there are 3 grades of asphalt. This will be your surface mix. This will be your intermediate mix, which will be your level up course. And this will be your base mix, which in the industry we call black base. So TxDOT recommends that once you use RAPs as a substitute for your hot mix asphalt, you pay attention to this column where the maximum ratio of recycled binder to total binder should be 35% for surface mixes, 40% for intermediate mixes, and 45% for base mixes. And the reason they do that is, as we said, binder coming out of RAS is a lot stiffer. So if you put if you put too much on your surface mixes, you'll have issues as it relates to raveling, alligator cracking, things of that nature. It will underperform. And as you can see, for RAS, they capped it at 5%. What we're doing. So we can't put RAS in asphalt if we do not have plants and processes to make it work. And looking across Texas, the green shows shingle manufacturers and the red shows plants that have capability to process asphalt shingles. Most of them are east of Austin for some reason. And if I look at this next slide, this is an approved list of entities that have been certified to process and use RAS across Texas. And I think in the Dallas area, I'm looking at R2R Recycling based in Plano, Texas. So they have met regulatory requirements. They have in place quality control plans and asbestos testing. They've got records of material processed for chain of custody. So they met all the requirements. So they're good to go. So considerations at the plant level to be able to use RAS will include the shingle types, of course. So is it going to be tear-off or plant waste? Your processing technique, how you're going to blend it, and how you're going to store it. So the next couple of slides speak to that. Processing. That's a typical machine that's used to grind RAS. And in essence, number one, it'll grind it down to proper size. And proper size proper size means 100% should pass that 3/8 inch. So by grinding it down to that size, it's easier to design mixes with your processed material. It alleviates issues with laydown. By laydown, we talk about constructability, workability. Is it easy to use by contractors out there on the roadway? and it facilitates better mixing in the drum at the plant level. Blending, you can blend it two ways. You can pre-blend it. It implies you mix your processed RAS with sand in a pog mill before introducing it into hot mix. Or alternatively, you just go ahead and you use one of your one of your wrap feed beans as a feed bean for your RAS. So it's introduced as a feed bean into conveyors down into the drum, and you've got asphalt coming in, you've got your rock coming in. It gets blended in here and into your silo. Storage. There are good and bad techniques for storing RAS once it's ground, and like it says on the slide, processed materials wants to stick back together. So how do you prevent it from sticking? You put it underneath a building, like you've seen in the picture. You want to keep it dry, and like I said previously, you can pre-blend it with wrap or sand. Next, what tests do we use to evaluate RAS once it's processed? Again, we want to keep asbestos out, we want to keep nails out, we want to keep wood out. We need a clean product. How do we do that? There's text item 217F part 3, which is determining deleterious material in recycled asphalt shingles. So it's this test that you need to establish if you've met that 0.5% criteria by TxDOT. And like it says, only asbestos-free shingles will be accepted for recycling. Nails should be removed from tear-off shingles during processing. This is a test we call in the field a performance test. It's called the Hamburg wheel test, and like the name indicates, you actually prepare peels of your asphalt with RAS, and then you subject it to a wheel that goes back and forth. And if you could end up with less than half an inch of indentation on your peel after 10,000 cycles, then it meets the Hamburg wheel requirement for performance. And if you look at the bars, this will be your conventional PG 64-22 mix. This is your mix with 20% wrap, and this is your mix with 5% RAS. So as you can see, with 20% wrap, you ratchet up the stiffness of your mix from 4,000 to about 10,000, and with just 5% RAS, you can ratchet up your Hamburg wheel from 4,000 to about 9,000. A couple more tests that you could run in the laboratory before you go out in the field to determine that it meets performance requirements will be, number one, the dynamic modulus test. It's a test you run on the combined product, and this test will tell you if your material will be resistant to rotting and fatigue cracking. The stiffness of binder test, on this you use a device called the dynamic stress rheometer, and by testing the binder, it's almost similar to the test you run in determining what will be the consistency of your toothpaste. You can tell if that material will meet binder requirements for introduction in hot mix. Low temperature cracking, you'll run what you call a direct tensile test, and that test helps you to determine how it's going to perform when you have winter freezes. As we told you prior, introducing RAS into hot mix makes it stiffer, and if it's stiffer and it gets cold, it's going to crack on you. So there is some threshold requirements, that way it doesn't crack on you in the field. And then lastly, fatigue tests. And essentially, fatigue is almost like you have a coat hanger, and you move it back and forth, and at some point it snaps. It's just similar to your roadway. As you've got vehicles going back and forth on it, it's doing this on you, and at some point it's going to crack. So what do we need in the product to make sure that it provides anywhere from 8 to 12 years of service before it cracks? What is state of the practice? What are the contractors doing out there to process the material? Number one, the material is delivered. In fact, in preparing this slide, I actually went out to a plant. This will be the Century plant in Houston. And as you can see, there's a contractor here delivering wrap. He has a little truck bed with the wrap, the shingles in it. And they've got a structure in place. In fact, I thought Texas, they claim we're not very smart, but there's some ingenuity in Texas. So what this guy does is he sits all the shingles on a tire with a chain. He drops the shingles on that tire. He comes to the plant, and the front end loader grabs the chain, drags that chain, and all of that RAS just pulls out. So it takes about less than 5 minutes to unload. I thought that was really smart. So once he delivers this, he gets credit. In fact, each time, I think the negotiated fee is about $30 per ton for him to drop it off there at the plant. Once he drops it off, it's stockpiled. And here's a typical RAS stockpile. You can't use it as is, you've got to process it. Here you got the grinder. So, in fact, out of that plant, they have a contractor who goes across the state of Texas and grinds for specific plants. And they pay him a fee per ton for grinding. And once ground, here's your processed shingle ready for introduction into hot mix. Next, how is it performing? At the onset, they had some issues, just like any new technology. Had fatigue cracking. The mix was drier, hard to put down. It was stiff. It was raveling. It had some premature failures. As you can see here in the picture, it's raveling. It looks aged. But we're constantly working out the bugs, and at this time, a well-designed hot mix asphalt containing less than 5% ground recycled asphalt shingles may perform as well. So with 5% RAS introduction, it gives the mix one great bump in the binder. So essentially, my virgin binder is the PG64-22. By introduction of 5% wrap into virgin binder, it kicks it up to a 70-22 consistency. And again, I said, if you run the Hamburg wheel test on it, it's a lot more stiffer. And the picture here on the right shows you a peel that was tested using the Hamburg, and you can see the slight dip after 10,000 cycles. Typical applications. Do we use RAS mixtures everywhere? No. You're not going to use it as a surface course for the Texas high-speed motorway. So we'll use it for level-up courses. We'll use it for temporary roads and detours. We'll use it for bond breaker courses. We'll use it for base courses. We'll use it for low-volume county roads. We'll use it for shoulders. And we'll use it for airport moor strips. Other uses, the aggregate that comes out from RAS processing can be used as structural fill material for highway embankments, Could be used for structural fill material for retaining walls. We could use it to prepare coal patch to repair potholes. We can use it for aggregate road bases, and we could use it for dust and erosion control for rural roads. Cost benefits. Pay attention to this one. The primary economic driver for asphalt shingle recycling is virgin asphalt cost savings. As you know, the price of liquid asphalt has gone up through the roof. So RAS now becomes a partial replacement of virgin asphalt. Potential savings, anywhere from $1 to $5 per ton in savings. If you look at the guy delivering shingles at the plant, tipping fee is $30. So he tips a ton, he gets $30 to $40. The grinding fee is about $35 to $40 per ton. Now look at the landfill disposal cost. If the guy with the truck had taken his truck to the landfill to dispose, it will take $120 per ton out of his pocket. So look at the swing. He would have been $120 in the hole, but by showing up at the plant and delivering, he's $40 ahead. So therefore, the total swing is 120 plus 40, which is $160 positive. For a contractor, that's good. The cost savings can be substantial. So if I look at my typical cost of type D PG 64-22, which is virgin asphalt, my cost at the plant is $40.70 per ton. With 5% shingles, that cost goes down to about $35.61. And as TexDOT indicated, you could mix both RAP and RAS. So if you've got 15% RAP and 5% shingles, you can bring down the cost to about $32.62 per ton. Huge savings. Bottom line, we talked about 13 million tons of shingle waste containing 25% liquid asphalt. So with 25% liquid asphalt, that translates to 3.2 million tons of reclaimable liquid from RAS if we were to process and use all the RAS available in the United States. And if we go with a conservative number of $475 of liquid asphalt per ton, that translates to $1.5 billion worth of liquid asphalt every year. So if we work smart, we can turn this economy around just by using RAS. List of projects in and around the Houston area. These are all county projects whereby they use 17% RAP and 3% RAS. We've got anywhere from US 59 to FM 563, Wharton, Galveston, Brazoria, Liberty County. They're using it. To conclude part one, there's this wise word by Don Brock I would like to share with you. We should treat our roads as assets, not consumables that can be used up, thrown away, and replaced with new ones. This came from me. High quality RAS mix comprises rock, asphalt, RAS, and air. Regrettably, poor quality RAS mix has the same ingredients. So know how to proportion it. It'll get you out of trouble. With that said, that concludes part one. And due to time constraints, I'll suggest you hold your question till after part two, which is right next. If you want to read up more, a little bit on RAS, here's some resources. The Recycled Materials Resource Center, the California Integrated Waste Management Bureau, the Construction and Demolition Recycling Association. Part two, recycle asphalt pavement in hot mix asphalt. Quick overview. In 2001, the United States residents, businesses, and institutions produced nearly 232 million tons of solid waste, which is approximately 4.5 pounds of waste per person per day, up from 2.7 pounds per person per day in 1960. So this means 5% of the world's population produces 40% of our waste. And we did that in 40 years. We doubled it. The obvious path for redemption is to recycle our waste. On recycled quantities, only 30% of our solid waste is recycled. That means of the 232 million tons, only 70 million tons were recycled away from landfills. So if we keep doing what we're doing, there may not be room in the landfills to put away our waste. Pavement recycling. Of the 2.6 million miles of paved roads in the United States, over 94% are surfaced with asphalt. So think about it, 94% asphalt, so concrete constitutes just 6% of our roadways nationally. So approximately 100 million tons of asphalt pavement is removed from existing roads each year. Of that amount, 80% is recycled back into new pavement. That is very good. Thus, reclaimed asphalt pavement is the world's most recycled material. Why use wrap? 3 reasons. It saves money, it saves money, it saves money. We use wrap because it's environmentally sensitive, and it's a way of being environmental stewards. We conserve natural resources by reusing aggregates and binder in wrap. We reduce landfill waste. We save energy because it's going to take trucks going back and forth if we were to go to the quarry and bring in new virgin material all the time, as opposed to reusing material that's already out there in the field. Then we've got government mandates, TCEQ, TxDOT. It's the environmentally friendly thing to do. So at 100 million tons, that's about 65 million cubic yards saved in landfill space. That's huge. And the positive is that there's no negative impact on air quality because we maintain the same standard for wrap as well as for natural HMA. Stakeholder mission and vision. Who are the stakeholders? It's me, a road user. You, who I believe would have engineers. We have people from the plants. We've got people from quarries. We're all stakeholders, and what are we looking for? We want it to be safe, we want it to be efficient, we want it to be environmentally sensitive, and we want it to be cost effective. Reclaimed asphalt pavement must be safe, it must meet specifications, it should perform well, it should be readily available, and be cost effective. Sources of wrap. Number 1, mailings. Old asphalt pavement, at the end of its service life, we milled it up. And as you can see, as we mill, we dump it in the truck. Down in Houston, what happens then is the city of Houston actually has a program with Century Asphalt where this truck now shows up at Century Asphalt. It goes through a scale, it's measured, and they've got an agreement as to what they will pay per ton of millings. And the city, in turn, will use that credit towards the purchase of hot mix from Century. And they do that, I think it's been going on for about 5-10 years now. Pretty smart.
If I can ask, we've got want to get moving on. If you could wrap up, we'll move to the presentation.
Absolutely.
5 minutes.
Okay. Demolitions and reject material from plants. How do we fractionate? It comes in where we've got large chunks. We break it up by processing. You got coarse wrap as well as fine wrap. So coarse wrap, you'll use it on your type A and type B black base. The fine wrap, you use it on your type C and type D hot mix. Mix designs, we use it for conventional mix design, which will be the Marshall mixes, which will be used for airports, and the Vim mixes, which will be used for roadways. We use it for performance design mixes, such as your coarse matrix high binder mixes, your super pave, and the stone mastics. We do not use it for open graded friction courses. This will be a typical gradation, where bin number 4 will be your coarse rock, bin number 3 your fine rock, bin number 2 your screenings, bin number 1 your sand, and then there you have your wrap, and you combine it, and it should meet your TexDOT master grading. Plant processing, essentially, your wrap comes in here, goes into the drum. Your cold feed, the various rocks come in here into the drum. Your asphalt comes in here into the drum. They all get mixed and into a silo and into a truck and out the door. That's a cold feed bin with your wrap. That's your drum. Batching, those are your trucks coming in, picking up hot mix asphalt with wrap. Wrap performance, widespread usage began in 1970, and it's been adopted by TexDOT counties, cities, and municipalities. List of projects, again, it's being used in the county, and as you can see, on the right-hand side, the various tonnage of material being used. Cost benefit, milling or pavement salvage costs. Cost to mill, you're looking at about $6.50 per ton. Excavate, haul, and stockpile, about $7 per ton. Reprocessing, which is grinding, about $5 per ton. On the virgin side, if I were to go to the quarry, coarse aggregate, $12 per ton, fine aggregate, $8 per ton, and your PG binder, $450 per ton, and it could go as high as $650 per ton. Cost savings using wrap. If I'm using, say, 25% wrap, my cost saving is on the order of about $5.50 per ton. So if I had 25% wrap in an intermediate mixture, it will save approximately 11% per ton. So assuming a 3-inch lift of roadway, for every 1 million resurfaced dollar, this will equate to approximately 2.2 lane miles of additional paving. So if I were a city engineer, I go to my mayor and say, hey, by using wrap, I can give you an additional 2.2 lane miles of roadway for every million. He'll listen to you. In summary, over 30 years of success, increased efficiency in the use of material resources. We've got technology out there to produce, test, and use wrap efficiently. Could be used to obtain LEED credits. Wrap has a long history of successful use. It's sustainable, it's economical, and it actually works. Questions?